Hello guys, welcome to eTrick Solution. In one of our last video, we have seen the concept of the multiplexer tree, in which we have designed a 4 to 1 multiplexer using 2 to 1 multiplexer. You can find the link of that video in this video description. In this video, we will see how we can implement this multiplexer tree using the Verilog HDL. And for the simulation purpose, we are going to use a wave-based application called EDA Playground. We have seen the getting started with EDA Playground in one of our last video, and you can find the link of that video in this video description also. Okay, so let us first discuss that how to write a Verilog code for a 4 to 1 multiplexer. And structural modeling is required to used to implement a multiplexer tree. Since 2 to 1 multiplexers are used to implement the 4 to 1 multiplexer, therefore first 2 to 1 multiplexer need to be implemented. So this is a block diagram of a 2 to 1 multiplexer in which A and B are the data inputs, S is the selection line and Y is the output. Now let us write the Verilog code for a 2 to 1 multiplexer. Verilog code is always start with the keyword module, and then my 2 to 1 multiplexer is the name of the module, and in the parenthesis there is a list of input and output. Then input and outputs are need to be defined. So A, B, and S are the input and Y is the output. And using this syntax, we can define the input output. After that, the logic description is required to be written. So we can implement the 2 to 1 multiplexer very easily by using the conditional assignment, in which we can use this ternary operator. This question mark is a ternary operator, and the meaning of this line is that when S is available or S is 1, then Y is equal to B, otherwise Y is equal to A. And then we can complete this code by writing the AND module. So this is the simple Verilog code to implement a 4 to 1, sorry, a 2 to 1 multiplexer. Now, once you have a 2 to 1 multiplexer module, then you can design a 4 to 1 multiplexer easily. So this is a 4 to 1 multiplexer design having D0, D1, D2, D3 are the 4 data lines, S1 and S0 are the selection line, and Y is the output. Now let us write the Verilog code for this multiplexer tree. So the Verilog code is always start with the module, and my 4 to 1 mux is the name of the module. And in the parenthesis, there is a list of input and output. Now next two lines defines the input output declaration. Now apart from these input and output, there are two signal there are two signal y1 and y2 which are not included in the entity of this top module, but they are connected internally. So to define this internal connection, there is a data type in the Verilog which is known as wire. So with the help of this data type wire, we can define the internal signals or the internal connections. Okay, now we can call the previously implemented 2 to 1 multiplexer one by one and then define the interconnection to have the 4 to 1 mux. So let us call the my 2 to 1 mux M1 means the multiplexer 1. We are calling 2 to 1 multiplexer 1, and in the parenthesis it defines the connection of the 2 to 1 multiplexer with the top module. And it is important to remember here that the order of the top module input output should be same as the order of the 2 to 1 mux module. Means here is the order is A, B, S, Y. That means D0 is connected to A, D1 is connected to B, S1 is connected to S, and Y1 is connected to Y. And as you can see in the figure, D0 is connected to A, D1 is connected to B, S is connected to S1, and Y is connected to Y1. Similarly, we can call the multiplexer 2 which is M2, and then again define the input and output with the top level in top module input output. And again you can see that the order is same as the previously implemented module, means D2 is connected to A, D2 is connected to A, D3 is connected to B, A- S is connected to S1, and Y is connected to Y2. And and let us call one more 2 to 1 multiplexer. The module is M3, and the connection, the order of the connection is same as the 2 to 1 multiplexer order. So you can see that the Y1 is connected to A, Y2 is connected to B, S0 is connected to S, and the Y is connected to final output Y. And we can complete this Verilog code by writing the AND module. So this is the implementation of multiplexer tree or 4 to 1 multiplexer using the Verilog HDL, and this style of modeling is known as the module instantiation. So in this way we can write a Verilog code for 4 to 1 multiplexer using a 2 to 1 multiplexer. Now let us move to the simulation part, and for the simulation we are going to use the EDA Playground. So just click on the EDA www.edaplayground.com and start the simulation. And so this is the home page of EDA Playground, in which at the right side you can see there is a design window, and at the left side you can see there is a test bench window. So before writing the code, I hope you remember the three important steps. The step number one is to logging from the Gmail account. The step two is to select the programming language, that is Verilog or VSDL. And the step three is to select the simulator. So here I'm selecting the iCrush Verilog 0.9.7 as the simulator. And you can put the name of a design by writing the name here. So let us take 4 cross 1 marks practice. Since we have uh, we have discussed the Verilog code for 2 to 1 and 4 to 1 multiplexer, so I am taking that code directly from there. So this is the code of 2 to 1 multiplexer, and this is the code of 4 to 1 multiplexer. This is same as we have discussed in the previous section. Now, in order to simulate this Verilog code, the test bench is required to be written. So let us write the test bench. The test bench is always start with the module and the name of the test bench module. So my 4 to 1 marks the underscore TB is the name of the 4 to 1. Now this is the input output declaration. So remember here that the inputs of the Verilog module is defined as the register in the testbench module, and the output of the Verilog module is defined as the wire in the testbench module. After that, the Verilog module is required to be connected with the testbench module, and for that we can use the module instantiation technique, in which the 4 to 1 multiplexer module is being called, and the connection of the input and output of the test bench is defined. So this is the syntax, in which dot d0 of the test bench is defined with the d0 of the 4 to 1 multiplexer module. Similarly, the d1 of the test bench is connected with the d1 of the multiplexer module. D2 of the test bench is connected to the D2 of the multiplexer module, and so on. Similarly, you can see S0 of the test bench is connected to S0 of the multiplexer, S1 of the test bench is connected to S1 of the multiplexer, and Y of the test bench is connected to Y of the multiplexer. So this is the module instantiation technique to call the Verilog module into the test bench. After that, we can provide the stimulus. So for that, first use the initial begin block, and these are the stimulus at the data input line. So D0, D1, D2, D3 are the data input line, and here we have we have defined the data, that is one tick B0 means one bit binary number having the value 0 is connected to D0. Similarly, logic 1 is connected to D1, logic 0 is connected to D0, and logic 1 is connected to D3. After that, we can provide the stimulus at the selection line. So this is the first combination in which the selection lines are 0 0. This is the second combination in which the selection lines are 0 1, and in between we have to provide a time delay. So hash 1 represents the 1 unit of delay between these two stimulus. Similarly, we can provide the other stimulus also. So here we have defined 1 0 as the selection line, and then the 1 1 at the selection line, and after that we can end the initial block and the AND module of the test bench module. Now, in order to display the stimulus value along with the output, the $display command is required to be inserted after each stimulus. So this is the syntax of $display command. So again, a unit of delay is required to insert the $display command, and this is the syntax in which first we define that the S0, S1, and Y are the binary variables, and then the list of the stimulus and the output. Similarly, we have to insert this command at each of the place after the stimulus. So after inserting the $display command, our test bench is ready, and we can simulate our 4 to 1 multiplexer. So for this, first save the design, and so when you click on the run command, then you can see that simulation results are obtained at the bottom window, and here you can see that the results are along with the variables. So you can see S0 0 and S1 0, Y is 0. Why? Because when 0 0 selection lines are when selection lines are 0 0, then D0 is connected to the output, and at the D0 the binary value 0 is connected, therefore output is 0. Similarly, you can see for the 0 1, the D1 is connected, and at D1 there is binary value 1, therefore output is 1, and similarly for the other combinations also. So this is the simulation result of our design, and if you want to display the simulation result using the waveform, so for that two more commands are required to be inserted, and these commands are the $dump file command and the $dump vars command. So a .vcd file is required to dump to obtain the waveform, and dump vars parenthesis 1 means the one level of hierarchy we are using to we want to simulate. So after inserting this command, let us click on the open EV wave after run, and then go to the run button again. And once you press the run button, then you can see that the waveform of your design uh, is appeared, and here you can see you have the D0, D1, D2, D3 data lines, and S0, S1 are the selection lines. So according to the value of the selection line, the output is defined. So when the selection lines are 0 0, output is 0, because at this moment the D0 is 0. When the selection lines are 0 1, then output is 1, because D1 is 1. When the selection lines are 1 0, then output is 0, because D2 is 0. And when the selection line are 1 1, then output is 1, because D3 is 1. So this is the waveform of the 4 to 1 multiplexer of our design. I hope now you are very well acquainted with the module instantiation technique of Verilog SDL, and you can use it according to your design or the specification. Thank you for watching this video, and please subscribe the channel for more such videos. Thank you.